Let's consider the marginal cost function. C prime of x equals negative 0.04x plus 29, where x represents the level of production and C prime of x, the marginal cost, and try to determine the cost function, C of x, from which it was derived. If at the production level of 100 items, the cost is known to be $7,050. So let's compute C prime of 590. Well, that's pretty straightforward because we already know the function C prime of x. We just need to plug 590 into it. So that would be negative 0.04 times 590 plus 29, which is, I'll use the calculator for that. So negative 0.04 times 590 plus 29. So that's 5.4. So that's the rate at which the cost is changing after producing 590 units. Integrate C prime of x to find the cost function C of x. All right, I think I'll come up to the side and do that. So what we're saying is C of x is the antiderivative of the derivative of C of x, of C prime of x. Sorry. So what we are doing is taking the antiderivative of C prime, which is negative 0.04x plus 29 dx. So when I find that antiderivative, it would be negative 0.04 times x squared over 2 plus 29x plus, and it's sort of unfortunate in marginal cost problems that we have the constant c here. It looks like the c in front. If you want to change that and call it k, that's fine. It's just an initial arbitrary constant, so it doesn't matter what letter you use. Negative 0.04 divided by 2 is negative 0.02x squared plus 29x plus k. Now, we do not have the cost function. The reason is this is a general solution for the cost function. What we need is a particular solution that fits some initial value. So back in the original problem, we were told that the production level of 100 items, we had a cost of $7,050. So what that means is for x, which is the production level, being 100, the y, which is the cost, the output value, is 7,050. So if I take this, which is supposed to be my C of x, then my cost at 100 units would be negative 0.02 times 100 squared plus 29 times 100 plus whatever k is. Well, that output level is supposed to be 7,050. The remaining variable in this part of the equation is just c. Well, sorry, force of habit, k. And because of that, we can now solve for it. So let's do that. And you probably need the calculator to help here. So negative 0.02 times 100 squared. Then plus 29 times 100. So that looks like negative 71. So negative 71 plus k is equal to 7,050. So now if I add 71 to the other side, so 7,050 plus 71, that gives me 7121. Oh, and you know, I just realized that looking back here, I see a plus in between here, so that's going to throw things off. You're probably yelling at me through the screen. I'll fix that. All right, so make that a multiplication. So that's 2,700. So that means, all right, so that means this is 2,700. And what I would need to do is subtract 2,700 from both sides. So 7,050 minus 2,700. That's 4,350. Okay, that probably makes a little bit more sense with the problem. So I have the cost function, c of x, is, let's see, negative 0.02 times x squared plus 29x plus 4,350. Okay. Now, if I want to compute the integral c of 590, effectively I just want to know the cost of producing 590 units. So that would just simply be, c of 590, and I plug that right into my cost function. So 590 squared plus 29 times 590 plus 4,350, and let's see what happens. So negative 0.02 times 590 squared plus 29 times 590, I'll be careful there this time, plus 4,350, and we get 14,498. So that would be the cost of producing 590 units.